move forward. So thank you guys for joining us this afternoon to talk and hear a little bit more about VM scale sets and deploying scale-out applications. My name is Drew McDaniel. I'm the lead program manager in the Azure team responsible for VMs, VM scale sets, and cloud services as well. And with me today, I'm joined by Varun. Varun, you want to introduce yourself?
Hi guys, my name is Varun. I'm also lead program manager in the VMs, VM scale sets, cloud services world.
So today we're going to try and keep it a little bit upbeat, a little bit exciting. We've got some interactivity, and we're going to start it off, and we've got some prizes. So everybody likes some swag, right? And so we've got some special swag. You can't find this downstairs. It's actually from the product team when we launched Azure Resource Manager. So we've got a little arm yourself. You know, I hear these can be used for drinking or candle holder. You know, whatever you want to do with it. So we've got some. We're using these for prizes, or maybe at the end, if you stump us with some questions, we'll also have some shot glasses. So to kick it off, I've got a question. How long do you expect it to take to deploy? How many? 20 instances.
20. Yep.
20 instances in a scale set. How long? Ubuntu 6, what do you got?
1604.
1604. 2 minutes? 4 minutes? 5? 8? 1? Wait, it's not Windows. All right, I hear 1. 1's the lowest we got. All right. So Varun, let's flip over and see what kind of wicked fast we can do.
All right, so I'm not going to count my typing in it, so.
No, this is the platform. Varun may be slow on here.
Yes. So I'm going to fill out the basic details. Select the region. Give it the password.
Well, I'm timing Varun for his review coming up, so don't worry about this. But you know, we're only going to really hold Azure to what it can do. And we're going to use ARM. I mean, these are the ARM shot glasses, so we're going to use Azure Resource Manager to report back the time.
Yeah, and as I'm going through the demo, this is the new full screen create for VMSS, so you will see like more tabs in here, and one of the tabs is instances. So I provide like 20 instances that I want. I'm not going to change all the other things, but you can add disks, change networking configurations, provide autoscale configurations. I'm not going to do that. The other thing I'm going to do is I'm going to have enable it for more than 100 instances and have max spread. Basically what this does is it will let your scale set grow to the region, or if you have a zone, let it grow to the zone, and basically find capacity where we find capacity. So you're not trying to like, you know, a cluster or whatever. So that being done, all right, moment of truth. This is not counting, hold on. All right, so I'm gonna go ahead and create.
So now we're gonna kick this off.
Okay.
I don't know, there is a little bit of networking beforehand. We're the compute team, so like if the networking's slow, it's really not our fault. Maybe storage, I don't know, the storage, disks are our fault as well, so okay. Let's see. Get a refresh, there we go. We got the networking stuff being created. Got the VM, so now we're creating the VM, is that right?
Yep, now networking is created. Now we are basically creating the VMs. And I'm going to hit refresh.
Let's see, we're probably 15, 20 seconds at this point.
We'll see. There you go, it's done.
Let's see what we got. Let's refresh that, look at the details.
Operation details. 29 seconds.
29 seconds. 20 VMs. So whoever had a minute, that was their closest. Should have been Price is Right. Somebody should have bet 1 second. All right. So at the end, you can pick up your shot glass for that price. And so we got some more of those through the session today. So what we're going to cover, it's going to be about VM scale sets and what you can do deploying large scale sets. And we're really going to talk through the tips and tricks, the best practices. And as we get towards the end, we're also going to talk a little bit about where we're going, some of the insights of what we're doing from the product team that you can see a little bit of it now and then help engage with us going forward to actually shape what we end up delivering as we go forward. And then finally, we're going to wrap up with a little bit of the troubleshooting tools that the team has added. So starting off, like, what is a scale set? And in fact, let's say I've got a couple prizes here. Who's using scale sets today? Show of hands. All right, let's do this. What's the largest, not a Microsoft person, who's got think they have the largest scale set in VMs? Anybody running something with at least 10 VMs? All right, a couple hands. 25? 100? 200? All right, 500? Are you guys running the same scale set? All right. I'm not going to make you bet again. Okay, so, all right, so how big is the scale set you're running? 10,000 cores, like full node VMs, so probably 300 machines around that. All right, so this will be your pair of shot glasses. Another thing, VM scale set, when were scale sets born? When were scale sets introduced? Anybody want to make a guess? What year? 16. It was previewed in 2015 and 16 at Build in April as it was released. So one for the winner there. Okay, so what is a scale set though? For those of you that are not using it, let me just go over a quick high level. Essentially a scale set starts with what we call a model. This is a description of what the scale set, the instances should look like. So the size, the OS configuration, whether you want it connected to a load balancer. And then you can simply say how many instances I want. In this case, 5 instances, and it'll spin those instances out. In the case that Varun had shown us, 20 instances, it'll spin out those 20 instances at just a little more than, or a little under 1 a second in that case. Oftentimes with scale sets, and where it really comes into its own is leveraging automatic scaling. So you scale up and down based on metrics. And so metrics flow into the autoscaling service. You can also use metrics from other resources in Azure. And so let's say that you have a load balancer in front of the scale set, and you want to have, a number of instances based on the amount of incoming connections or flows or requests. And so that's also a common thing. You could also do it off of queues. And so any resource that's used in the application, as long as that has a metric, then you can queue off of that from the autoscale service. And then the autoscale service will update the instance count as needed to increase or decrease the number of instances. You can also, and so that's kind of the common way that the instances are modified, but you can also modify it by updating the model and then having the model apply out to the instances. So here, I set the size to large, and it's going to go through and update the instances. And in fact, you have full control on how you want to do that. The scale set has the capability to run either in manual update mode, so you update the model and then you select instance by instance that you want updated, or there's 2 forms of automatic. One is just automatic and it randomly goes out and it updates across instances. And the second is a little more interesting, which is leverages a health monitor on the instance, and it will go out and update the instances a set at a time, making sure the instance updates and is healthy before it moves on. Typically, the best practice recommendation is to use that health monitoring version of updates, but you have the flexibility to do it in different ways as you want. So talking about scaling, just some of the numbers and where you get with the scale set. This is just looking at kind of the history of where we have. The most common alternative to a scale set is what we call an availability set. So an availability set with Azure Resource Manager caps out at 200 instances. Actually, if you go back to the classic VMs, it's even smaller at 50 instances. But as you move forward with VM custom images and VMSS with custom images, you can get up to 600 instances. Again, you want to use that checkbox for more than 100 instances that Varun showed earlier. Then you can move with VMSS with shared image gallery, and we'll talk a little bit about shared image gallery. You can get up to 1,000 instances. The same thing you can do with platform instances or cross-zone. And so next kind of question prize here, when we're talking, so this is scale set itself. How many VMs, though, could you run in a subscription in a region? So we can do at least 3,000 in a single scale set. Anybody want to guess how many instances you can get in a single subscription? What was it? 800? 1,800? Okay, good. Anybody else? 10,000? 10,000 more, it used to be, we're actually more than that now. 30, close. It's 25,000 instances per region. If you have, we actually have, let's see, about 40 regions in our biggest public cloud. So what's that end up being? About 1 million instances total in a subscription that's possible. But 30,000 is the winner, close to that. So that's the scaling that you can do. Now with the scale set though, you really want to start looking at automation. Because you're deploying those instances, you're scaling up and down, it's important to have it fully automated. You really don't want to use scale sets where you're manually going and configuring the instances, especially if you're going to be at scale. And so you kind of have two options for configuration. One is on the base image, you can either use a platform image or a marketplace image and then configure it after the fact. And this is a really nice solution. You're getting the updated Ubuntu or SUSE or Windows images. Microsoft or the Linux distributor is patching them for you. And so it's a nice way to have those images automatically updated for you, but then you have to configure after the fact. The next option, though, is what we call a shared image gallery, and that's where you configure the image yourself, do the patching and put your software on there, and then put it into the shared image gallery, and we'll show how that can be used to automatically push out to the VM scale set. Now within the VM, then you have really 3 options for doing configuration. There's a little bit more, but these are the 3 most common. Cloud init is a function that is available on basically all of our Linux distributions. And it's kind of a fire and forget configuration. You give it a set of scripts or things that you want the image to download, and the VM will go download and run those for you. But it is a little fire and forget. It doesn't come back and tell you the exact result of that. The next one is what we call custom script extension, and this leverages the Azure or the VM extension model, where we download the script, we execute that, and provided that returns with a success code, it shows back up in the platform as a successful operation. And so you can actually see a little bit more detail about that. You can also use the extensions for configuring like domain join or other purposes to configure the VM. And the last one on there is not as typically used for deployment time, but the run command is a way to send commands to instances through the API layer so that you can configure policy and other things. And so we see customers using the run command to go and make sure all of the instances are in a specific state with regard to policy and control. And so it's a poor man's policy tool. There's also, of course, Azure Security Center and other policy tools that can be used in place of that, but the run command is a very useful thing there. Now we talked a little bit about the different options. I want to kind of pivot in the patching. One of the main challenges and efforts that is taken on is keeping instances updated for the patching purposes. Now, what we use today and what we recommend, in fact, if you look at our internal customers, by and large, so for example, the folks running SQL Server systems, they will use this notion of automatic OS updates. And what that is a way for the VM scale set to automatically be updated when there's a new platform image. And so when a new platform image is published, a new version, let's say that you're using 2019, Windows Server 2019, you're running the September version of that. When the October version of patching level of that is made available, we will start rolling that out. Now, we require the VM scale set to use the health probe integrated model because it's an automatic rollout of a new operating system. And so the health probing will make sure that it is a good image and moves that forward. And then those extensions are run after the image is updated so you can reconfigure the software within the VM. And any of the persistent data will remain. Now this is a great solution, and it's pretty easy to enable through just setting the automatic OS upgrade policy, and it will automatically update that across the scale set. There's a service that's monitoring for the operation. And so it's a nice thing. However, today, this is limited to our platform images, our Windows-based image, Linux-based image. But what we really want, what we've been hearing a lot of customers ask for, is integration with this other thing, what's called the shared image gallery. And the shared image gallery is, think about it as a custom image on steroids. You have a custom image that you've created, and then you put it into this gallery, and it will replicate it around the world. It will take multiple copies of that, and it basically makes a platform image repository of your own. And so with the shared image gallery, because it's integrated with Azure Resource Manager, you can actually set RBAC access on that. And so a user in a single AAD tenant, you can do cross AAD tenants, and there, if you pull down the deck, there's a link to the documentation, but it's a little bit more work there. But you can use straight RBAC for within the same AAD tenant, and then you can deploy to any subscription that that user has access to. And so this is a great way to scale that out. It's also something that even if you're not scaling across subscriptions, the fact that it has multiple replicas behind the scenes actually shows a much, much better performance than a custom image. In fact, some customers are seeing up to 30 or 40% reduction in the time to deploy instances just by moving to the shared image gallery as compared to a custom image when they were deploying at scale. And this will allow you to then replicate that image out across the various regions of Azure. You can even put different versions across different regions and make that available. And so what we're doing now is announcing the capability to combine the shared image gallery with the Auto OS update so that you can actually leverage that. We do have a link. It is a preview right now, and so if you click on the link, it'll give you the instructions on how you enable that in your subscription and how you provide feedback. But to show us more about this and what it looks like in real life, Varun, why don't you show us a demo?
Yep. So as Drew just talked about shared image galleries, let me just quickly walk through like what it will look like on the portal. So I've created the shared image gallery, and once I create this, I can add this image definition. So I've added the image definition of phone app, so I can go to that. Now, a lot of customers deploy, for custom images, they deploy their application as part of the image. Now, for example, you have a new image which you've updated, either due to patching or a new app version or whatever. You can go to image versions, and then you can say, I want to add a new version. And you add a new version, I can select Central US, and it will give me, I have to select a version number, and then I have to select the image that I need. So in this case, I'm going to be selecting an image without IIS because we made a mistake. The other thing that we shut off IIS, that was a mistake that we did. The other thing that I want to note is this exclude from latest. So one of the things that you would notice is this is saying no. What if I say if it's yes? Basically what this flag tells shared image gallery and all the VMSS that get deployed with this shared image gallery is that this particular version is not the latest, so do not use this version for new deployments or any upgrades. So you can control how you roll out these images to your applications and updates. So if I say yes, exclude this, and then I can add regions. So I'm just going to go ahead and say review and create. This is going to take some time because it has to do a deep copy, replicate across the region and whatnot. So let me go back to a shared image gallery that I've already created. So if you look at this, this is the one that I already had created, in which the base was good, but the versions.
So Varun, this would be one you'd created, tested to make sure it was good, but you weren't not ready to roll this out to everybody yet?
Yes. Okay. So for this one, what I would do is, I'll go to my shared image galleries. I'll go to my image. And then if I look at my image definitions, I can go to the image versions. And if you look at this image 1.0.1, it is set to be excluded. So now I know this has been replicated everywhere. Now I can go to my PowerShell. Let me zoom in a little bit. So if you look at there is a CLI command where I can go ahead and I can update the definition and the version and say this one is ready for me to roll out. So let me execute that. And as I am going in, including that as my latest version, all the scale sets that have been created with this version, so I have a couple of scale sets that have been created using this version. I have this scale set that I've created using that shared image gallery. And if you look at the OS configurations, the automatic OS upgrades are enabled on this. Let me go back to my PowerShell and see if that is executed. We let it execute. Basically, it's setting the reference for that image to include it as the latest version. Hopefully, it should come back soon.
And so, Varun, when you set this, is it going to flip it for every region where you've replicated that image all at once then?
Yes.
So to start rolling out, so everybody's going to be on the consistent latest version across all of the scale sets using this golden image.
Correct. So there's two levels of control that you have. The first level of control is which regions do you push it out to, so you can control the regions that it needs to go to. And the second one is you can also control when it becomes available for you to make it available for new scale sets to be created. So let's go back and see, is it just the CLI, which is slow, or let me navigate back to my shared image gallery.
So you're proving that it's a live demo just by making it slow for us, yes?
Yes. One was fast, I had to make the other one slow.
There you go.
Okay, so this is basically, the CLI is not returned, but this is saying that it is part of the image. Now, if I would go back to my scale set, what I would hope to notice is on my instances, it basically will start updating the instances in a 20% rolling fashion. So all of these instances are running right now, but what happened is, as we start to roll out these changes, the instances we'll take 20% of your instances, apply this new image, and look at the health for those instances. And if they become healthy, we'll roll forward. If the instances are not healthy, we'll fail them and we'll roll back to the previous good version of the image that you have. So your application, your availability is not impacted at any given point in time. So platform takes care of a person like me who stopped the IIS on the image that I rolled out where IIS should be enabled. So I did this yesterday, and I have I'm not going to wait for the results to come back. But you can see if you look at the OS history for for my scale set, what I would notice, and I hope the resolution is okay. What I would notice here is that in the rollback info, you will see that the 2 instances were rolled back. In my progress, you would notice that I had 2 instances that failed. So this scale set had 20 instances. We started with 2 instances. As soon as they fail, and by failing, what we mean here is the load balancer probe failed. And as soon as it failed, we noticed the state, and we took those 2 instances, and we rolled back to the previous good known state, and we did not go forward. Now, as an administrator, you can come back and say like, oh, I had this failed state. You can go inspect the image, figure out the issue with it, and as soon as you publish the new version of the image, we will kick off the update again. So you don't have to go and take an action because your availability is ready for your customers, and now you're publishing a new version, and that will just roll forward. The other good version, if I would have not stopped the IIS on my image, what you would have noticed is you would have just noticed successful state here, and you would have said like, 2 instances were updated, and it will just basically just keep on going forward till all the 20 are done, and basically stop at that point in time. So that's it.
Excellent. Thanks, Varun. And so this is starting to show, and you'll see this as a theme through here, is what we're doing is making sure that you can run at internet speed, at cloud speed, update things, do constant deployments and constant updates, but with all the checks and balances built in, such that if something happens or you have a hiccup, it rolls back. And so it allows you to actually run quickly, make updates, and be agile without actually being impacted if somebody made a mistake. So let's talk a little bit about managing the instances at scale. There's a couple things that when we put this in and we see this is, again, we talk about the scale sets often in this auto-scaling model, but there are cases where one of the instances or a handful of instances in the scale set is a little bit special. Maybe those instances are running some kind of a controlling software or directory software. It's also doing normal operations, but that instance you really don't want to be deleted. And so you can mark instances for protect from scale-in, and whenever there's an automatic scale-in operation, those instances will not be modified or not be scaled in and just kept running. And so you can set that up for kind of your special instances that you want to keep always running. The second thing is what we call protect from scale-in actions. So if you saw when I updated the size, or if you're updating the operating system, again, you may have some instances that you want to treat special. Do a little bit of server hugging on those, and those you can mark protect from scale-in actions, or scale set actions, and that will both prevent it from being scaled in, as well as any of those scale set operations will skip over that instance. We also see customers using the combination of those if they have one instance they want to take out for debugging purposes. Something went wrong, I want to take it out, I want to kind of play with it and debug it. Those can be very useful. And then the third kind of a scale configuration setting is around scale-in policy. So by default, the platform will balance the number of instances across availability zones and then fault domains, which are racks in the data center inside the zone. But in some cases, you actually want to modify that. So the two options you have are newest VM or oldest VM are the ones selected. And so, for example, we have customers where if they're deploying a new image, they want to push that out. They only kind of want to sample that on a handful of images, and so the scaled out VMs will get the new image, but they set the newest VM to be the one that's scaled in. And so something scales out and scales in, and so they're getting a little bit of testing on the new image until such point that they decide the image is good, and they flip it the other way, and they say, I want, when I do a scale-in operation, remove the oldest VM, and that will remove those old ones, and so that's a way to kind of update things. It's a little bit of a blue-green type of deployment configuration without actually going and scaling out a whole separate instance. The other one here is what we call instance termination notification, is at least what we're calling it in the portal. We talk about it, we call it application draining. What this does is gives a signal to the instance in a configurable time of 5 to 15 minutes before the instance is scaled in or deleted, so that you can take action. And so we were just talking a little bit earlier today, using this as something as an example. If you were joining instances to a domain controller, an Active Directory domain, on-premises AD, you could use this to get a signal when the instance is going to be deleted, and then execute a script on the machine to unjoin it from the domain. And then as soon as you complete this scheduled task, the machine will automatically be deleted. And so you configure it for at least 5 to 15 minutes, but if you complete the cleanup operations faster, the machine will get deleted. So it enables that cleanup and connection draining. So the next thing I wanted to introduce and announce, this is new functionality called instance replace. And so common operation is with a load balancer and an application probe. Now the health probe on the load balancer is detecting when there is a machine is down and it's not sending traffic to the instance. But today, a VM scale set keeps that instance up. It looks healthy to the platform because it's still running, but maybe IIS failed, or maybe the application failed, or even the machine bug checked, but it still looks like it's running. We'll not send traffic from the load balancer, but with this new functionality, we'll actually replace that instance using a similar functionality that we were just demoing with the OS update. And so you can also have a configurable timeout before the instance replace, and it integrates with the application health probe. And so, Varun, let's switch over and I'll give a quick demo of this. So what we've got here is I've got a scale set, again, just like in that picture we're showing, I've got a load balancer in front of it and the scale set behind it. And it's a pretty basic scale set. I've got an instance, and if we look, I'm going to actually dig into the individual instance in the set here and look at its public IP address, and we'll see that it's just a basic IIS page. And so, that would be your applications up and running, and I want to simulate a failure, so I'm actually going to go to the machine here, hopefully, and I'm just going to stop IIS, and this is simulating a failure of the web server. And of course, if we go to the machine and refresh, we'll see that it's down. So it's failing. However, because I have this configured with a load balancer, so the load balancer is in front, and if I look at the server through the load balancer IP address, because there's two instances behind here, and again, you really want to deploy in a HA manner. So from customers, they're not seeing downtime at this point in time. But I had two instances, but only one's up, and so it's taking all of the load, and I'd really like to have that other one replaced. But Azure, if we look at from Azure's view of the instance, the scale set itself, if I go down to resource health, and it's going to show that as healthy because the hardware's still running. It doesn't know, or should show it as healthy, that the machine's down. However, if we look at the load balancer, let me actually refresh here. We're going to see that the load balancer is configured with a probe against HTTP port 80. And as soon as the load balancer is seeing that start failing, then the VM scale set's actually going to pick that up, and it's going to automatically replace that instance with the configuration from the template. And so that's how we'll keep the instance updated, and so it maintains that target count. So the scale set was targeted to be at two instances, and it will maintain that through the process. There we go. And so you see the load balancer heading towards 0. As soon as that reaches 0 and it hits that timeout, the scale set, because it's been configured with this additional configuration of automatic repair. So basically, I have enabled automatic repairs to be true. I've said there's no grace period. The grace period is when you deploy, how long it is given to come and be healthy. So, because sometimes you need to configure things before you can actually respond to the health probe. And then this is also very useful, is how many instances can be down at any point in time. So if you have a scale set, say you've got 50 instances, and something went wrong and the health probe started failing, but it's actually working, I might set this to 25%, and it would start replacing 25% of them, but then it would stop. And normally you want to hook this up into an alerting mechanism. So you say, hey, the instances are being replaced, and so you can go look and see what's going on. And this is just kind of a safety net to make sure it doesn't take all of your instances down. And so if it's behaving as we expect, we should see the scale set itself. If we look at the scale set instances, we see here that we've got a new instance being created. It's in the stop state and coming up. Previously, the instance was 6, and so this is a new instance replacing that. And so it will automatically come back up. And here shortly, once that's up, then you would see the dashboard for the health start showing a new instance, and the instance would come up and be healthy again. And so it's a nice way to, again, allow for some safety nets in your system. And so again, you can run really fast, you can scale and deploy things, and we'll back you up to keep things running. All right, can we switch back to the slides? Okay, so now I want to pivot in. This is a set of stuff that is recommendations. Most of this is just general recommendation. I'll go through this fairly quickly, and Varun had touched on that a bit earlier. When you deploy instances, there is the configuration of multi-placement group or single placement group. That's the scaling above 100. Our recommendation is to always use multi-placement group, and again, it allows for all of the capacity in the region to be leveraged for that scale set. The one exception for that is if you're running something like a NoSQL, like a Cassandra database that's replicating data amongst the individual machines. In that case, they need to be on needs to know what fault domains there are, and so you limit that to a single placement group. But then again, those are well under 100 instances typically. When you deploy, you can also configure the number of fault domains from 2 to 5 if you want to have specific fault domain counts. But again, what we recommend is what we call max spreading. And that, again, just spreads out the instances across as much capacity as it can across individual racks to keep a high availability. But it's not set to a very specific number of 2 through 5.
That's fault domain 1, essentially.
Yes. And yes, and in the template, you'll see that listed as fault domain equals 1 is what we call is max spreading. Over provisioning is a functionality that when Varun deployed 20 instances, it actually deployed a few extra, and the idea being the first of the 20 that are successful are returned. And so the default and the recommendation is turn on over provisioning. If you're running scripts, so like for example, if you're joining domain, you can override that to say over provision, but only run the scripts on the instances that are going to be maintained. And so that kind of gives you the best of both worlds. Shared image gallery, we mentioned that you can see some great improvements with shared image gallery, so I'd recommend that. We have functionality called bulk instance get, and so this is getting the status. That is coming soon. It's not available yet, and so we'll update that when that's available and look for the service update on that. And then finally, with the load balancer, There is a thing called the basic load balancer. That's only available with a smaller set of instances, but generally you want to use the standard load balancer. The standard load balancer is required for multi-placement groups and spreading across zones. That is the standard load balancer or app gateway. App gateway is layer 7 HTTP-based load balancer. The load balancer is a layer 4 load balancer. Okay, so the next thing I want to kind of touch on, and this is a little bit looking forward of what we're doing, which is today we have this notion of scale sets and standard VMs. And so the standard VMs set construct is availability sets. Scale set is a scale set. And this is kind of talked about, has anybody heard the term pets versus cattle? Some? Okay. For those of you who haven't, there's this notion that, an allegory that's used, which is, or not an allegory, but a relation here, which is if you're individually managing individual instances, it's like treating a pet, where if you're running things in kind of a factory automated way, it's really cattle. And in fact, if you look at our instance replace, that's like cattle mentality in its finest. Something's unhealthy, shoot it in the head, replace it. Now, sometimes you need there's validity in using both models, but what we're doing here is trying to combine these two. And so today you have full flexibility with the availability set. You can have different sizes. Where a scale set, it's only one size at a time. Availability sets are legacy; they don't support availability zones. Where scale sets are much more flexible, supporting zones. There's no auto scale support. And so as you can see, this kind of, on the availability set, there's less things that are there. On the scale set, we have more functionality. Low priority instances are now called spot instances and more. And so what we're doing and what we're announcing today is the start of what we're calling VM mode VM scale set. And this brings the flexibility and customization of VMs together with the scale and automation of a scale set. Now, I will let you know that this is just the start, and in fact, you can join us through a public Teams channel to engage with the engineering team. I'll have Varun show us a little bit about what it looks like right now, and as you'll see, it's just kind of a start of where we're going.
It's, as Drew talked about, we have like two grouping mechanisms, right? Like, so trying to combine them to just one grouping mechanism. So what I can do is I can go and actually, I can go back to home. I can go back to my VM scale sets. I can say I want to create a new virtual machine scale set. I can create a new scale set. And one of the things that you would notice is this new orchestration mode, this orchestrator mode here. And basically, it has two options. It has virtual machine scales, virtual machines, and scale set VMs. So virtual machines is the newer mode that we're adding to scale sets. So when I would click, so if I zoom a little higher, when I click virtual machines, you see a whole lot of options for like scaling and management kind of go away. As Drew mentioned, we are just starting this journey. So I select virtual machines. I can give it a name.
When we're done, is there going to be all of those options available, Varun?
Yes.
Good answer.
The idea here is that you should see the same experience from a deployment standpoint for both VMs and scale set VMs, the pet and kettle. So you can have the same deployment experience, management experience, and how you manage a VM is on your workload or your deployment type. We'll give the options to you to manage them.
What about migration? Are you going to give migration to this new thing?
Let's first create one.
Come on, we will have migration.
Yes, we will have migration. So I'm going to create this with two fault domains. I'm going to basically say create. What it's going to do, it's going to create an empty scale set for me. And when the deployment will finish, this should be fast. If I go to the resource, it basically is an empty scale set, has no instances. Now, when I go to my...
This follows kind of the availability set construct that exists today, right?
Correct. So now, if I go to my virtual machine, you will start to see a new thing. I'll go to and add a virtual machine. I'll provide a name, resource group, a name, South Central, I think that's what I created it in. And the availability options, I will start to see virtual machine scale sets now. Instead of earlier, I just had availability set and availability zones. Now, the virtual machine scale set that I created was in a zone. So the VMs that I will deploy to it will go to that particular zone. So in availability sets, you did not have an option to deploy a quorum of VMs to a zone. By using this new preview feature, you can deploy a quorum of VMs to a particular zone, so you get zonal isolation. You can deploy those set of VMs into 2 or 3 zones. If a zone goes down, your availability for your VMs do not go down, so you have more availability available to you. Let me just provide a password. And when I create this, it's basically going to deploy the VM into that scale set. Say create. So as this gets deployed, it's going to deploy into that scale set in South Central US. And if it was a zone, it will deploy it into that zone. And you can expand this VM. And as we were talking about, this is the start of our journey. We are enabling this feature. All the features that you saw go away, which is auto-scale management. Our plan is to add all of these features to this new mode in coming, in future. And we're doing that work pretty aggressively. The other thing that Drew mentioned was migration. So we are also working on giving a migration API for your existing availability sets to be migrated into scale sets. So you would be able to migrate your existing regional availability sets into a regional scale set. And then as new features come up, you will be able to just opt into those features and start using them. So our request here is like, go to the Teams channel, engage with us, provide us your use cases, provide us your scenarios so that we can validate our designs and we can work with you to enable these scenarios.
Great, thank you, Varun. This kind of brings the pets and cattle together into one group. You kind of got your cattle and your sheepdogs or whatever, you're maintaining the cattle, your pets. So, all right, let's go through real quick the last thing I want to talk about, troubleshooting, especially at scale. One of the things we've introduced recently, if you have an instance that was failed and not booting, one of the challenges is how to get that working again. Say you have file system corruption. So you've got a machine that's problematic. We now have this capability that you can execute from either Cloud Shell or the Azure CLI to institute a VM repair. And what that does is shuts down the original VM, and it creates a repair VM and attaches a copy of the original operating system disk to that repair VM. Once it's over there mounted on that repair rack, if you will, you can execute a set of scripts. So for example, here we're executing a script to run check disk against that, the copy of the OS disk from the bad VM. And there's a set of scripts that you can run. Those scripts are integrated through GitHub, so we can expand and add more to those. But here again, it runs a script to repair the corruption on the VM or the OS disk. And then once it's done, shuts down and deletes the repair VM, saves the original OS disk, and just replaces the repaired disk, so you have the machine working again. And so this is a set of tools that we have to make it easier to recover instances that had some form of corruption. You can use it with a scale set. You can also use this a little bit more with the pet type VMs, but something we wanted to share is newly available. So with that, I want to show, there's a couple, more than a couple, I guess, VM-related talks. So these are sessions that have already completed, that if you wanted to grab a screenshot of this to watch those. Then we've got one more today following this session on Ultra Disk. This is our high-performance disk. A couple on Wednesday. And then we've got multiple sessions on VMs on Thursday that go into some of the deeper depths of the scale sets, updating maintenance, some Linux-related things, and then also a couple on Friday. So with that, I want to thank you for your time and ask, please fill out the evaluation. Let Varun and I know how we did. Please collect the prizes up here. And actually, if we do have about 6 more, so if there's anybody that didn't win but would like a shot glass, or sorry, candle holder, please come up and join us. Thank you.